Now there are two technologies, as I said, solar PV technology or solar thermal. And Mr. Naran was talking about harmonics, which is coming mainly from the solar PV because of the inverter system there. But if we are not using solar PV and using solar thermal, then this problem is totally eliminated. These, you can see the sun. The sun is sunlights are falling on solar PV panels, which is silicon-based panels. And from there, the DC power is generated, which is taken to inverter, which you can see in the center bottom. From there, DC power is converted to AC, and it is fed to the system through the panels and transformer system. And of course, a metering is also there. So this is the PV, which is very simple, and you can see all the PV projects all across, because the prices of PV has come down drastically, and this becomes a standalone kind of project all over India. Yeah, this is a PV project you might have seen when you are going across anywhere through train or bus or anywhere. You can see these kind of modules, this kind of panels, which are everywhere on countryside and many places. All degraded lands are used for this. Yeah, here in the center, you can see the module. This is the unit of solar PV project. On the left, you can see cell, which is a 6x6 kind of structure, polycrystalline or similar kind of material. And on the right, you can see the array, which constitute the solar PV project. Now we come to solar thermal. Yeah, there are four kinds of technologies. Solar trough, we will see in picture right now. The next is concentrated linear Fresnel reflector. These are cheaper version, and we have used in the NTPC Dadri this technology. The third is solar tower, and the fourth is dish technology. So solar trough, yeah, you can see the trough. They are parabolic trough, and by definition, if it is a parabola, we'll be focusing on its focal point. So we will keep a tube in which some liquid, maybe oil or molten salt, will be flowing, and the heat is captured through this tube. So that tube is taking the heat to some heat exchanger. Oil will be heating water, and steam will be generated, and that steam will run the turbine. So it is the instead of a boiler, coal-fired or gas-fired boiler, this solar trough is using to give the heat. So this is the first kind of technology. In this, the temperature can go up to 400 degree centigrade, and that will be used in the heat exchanger for generating steam. So you can see the size of the solar trough. You can see 3 persons walking in between. So you can compare the sizes. So it's a huge, gigantic, and it is spread all across. And the turbine and this heat exchanger will be in one center of the plant. This is a solar trough from a closer angle. You can see the angle. It's a trough kind of thing, parabolic trough. And the tube, you can see, it is white. So you can make out that all the light is focusing on this. This is the trough from a side view, and you can see as the sun is moving from east to west, the trough is also facing it. And there is a motor, it will keep on moving it so that it is focusing sun all the time, because the rays have to come on its principal axis. Then only it will concentrate on the focus where the tube is there. Okay. Yeah, this is 𝗧𝗵𝗲. This technology is used in Dadri, and you can see the mirrors which have been put on a flat platform on the bottom, and the mirror pieces can move on its own. So the power required to move the glass pieces or mirrors is less. And you can see the receiver on the top, the white line, that is a receiver, because all the sun rays are concentrating there. So you can make out that that's a bright white light. And here the temperature will go up to say 400 to 450 degree. And we normally run oil or water through these tubes, and that will become steam. Or if oil is going, it will carry heat, and it will, in a heat exchanger, it will convert water to steam. Picture of the same thing. Sun is on the one side. You can see the mirrors are at different angles. It is not on the same angle, because if they have to reflect the sun rays to a single point at the top point, each mirror has to be turned in a different angle. and that is computerized program is used to calculate the exact angle of each mirror, and at every point it has to change because the sun will go from east to west, and the mirror angle has to change continuously so that the reflected rays are concentrated on the top receiver. This is another technology, solar tower. Here many heliostats are there. I will tell you what is heliostat. You can see the sun rays which are coming down on the ground, and the reflectors are there, single supported reflectors. They are called heliostat. The name heliostat is coming because helios means sun and stat means static. So the image of the sun has been made static, and static at the central tower receiver, which you can see in this picture on the tower top. So wherever the sun is there, the reflected image will be on the receiver. That's why these reflectors are called heliostats. And from there, the heat is captured through a boiler tube kind of structure, and the heat is taken out. Normally, the temperature goes up to 1000 degrees because there can be infinite number of heliostats around the tower. And then in this, even oil cannot be used because the breakdown temperature is around 400-450 degrees. So we use molten salt here. Molten salt is taking heat from there, and it can be stored in a tank, or it can be taken to a heat exchanger where the water will be heated to steam, supersaturated steam, and that steam will be used in the turbine. And when the molten salt is at a lesser temperature, it can be stored in another tank, and then it can be brought back to the solar tower. So this tank can be used as a storage also, so that when sun is not there, even that time the turbine can be operated. So this is the advantage of this technology with molten salt. And molten salt as having a very high specific heat, lesser quantity of storage can run a bigger turbine. Yeah, this is a real picture of a solar tower. You can see the receiver at the top of the tower. The tower can be as high as 130 meters. Heliostats all around it, and you can see the light being reflected from there. This is another structure. It is a civil structure, and heliostats all around it. Yeah, this is one heliostat. You can see it can track sun in 2 axes. Means it can go from east to west and also in the north to south also, because the sun moves from north to south also during winter and summers. So it has to take care of that movement also, so that the reflected rays are going exactly at the receiver at the top. That's why this has 2 axis tracking. You can see how the reflected rays are coming to the tower, and each heliostat is controlled by computerized program so that the angle is fixed and the rays are exactly pointed towards the receiver. This is a solar dish technology. This is also 2 axis tracking, but here the receiver is very near at the focal point. This is a parabolic trough in 2 sides, paraboloid you can say. In both sides the curvature is there, so it is a point concentration. Here also the temperature goes up to 1000 degrees. Here the receiver is a tube structure, run either oil or molten salt, and then the liquid is taken out and brought to a heat exchanger. Yeah, this is the geometry. It has to always face the sun so that the reflected rays are concentrated at a single point. So with 2 axis tracking, it will always see the sun only. Yeah, you can have n number of dishes, and there's no error here. In solar tower, even if one heliostat is not working properly, the reflected rays can go to somewhere else. But here the concentration is very effective because the receiver is very near to the reflectors. Yeah, this is the solar thermal hybrid power plant which we are using in Dadri. You can see in your left the solar trough total structure, and then the hot oil is coming to a heat exchanger which is in the center, and you see the dotted line, vertical dotted line. Left of that has been commissioned now with the turbine of 200 megawatt, which is 210 to be specific, which was already there. So it is a hybrid project the solar part has been added onto the unit, and the solar component has been installed in an empty land near the unit. So here, instead of boiler, rather in addition to the boiler, the heat is added to HP heater, 5 and 6, in between 5 and 6. So when the solar project is running, the boiler coal firing is reduced and the same amount of steam goes to it. So there is an advantage of maintaining the load even with a lower coal firing. So coal can be stored, and when the solar project is not operating, say during night hours, then the only thing they have to do is to increase coal firing to maintain the load factor. So this is the advantage of this hybrid project. You can see the picture of those actual picture. You can see the CLFR component available there. Next, please. Yeah, you can see the Dadri cooling towers in the background, and this is this solar element is placed there. Yeah, this is another picture. You can see the length, and you can see the top receiver bright white. I don't know if you are able to see or not, but this is in working condition, so it is in white, bright light is there reflected, and the receiver is working as of now. The solar thermal hybrid power advantages, you can see the existing TG and evacuation system is being used, so the cost of green power is less there. Coal comparatively less. Coal can be saved when the sun is shining. Environment friendly augmentation, because there will be less pollution because of this. Green power at a lower capital cost because the turbine is already there. And let me share with you, since the turbine is 200 megawatt capacity, the efficiency of the turbine is more. Instead of putting a 50 megawatt turbine or 15 megawatt turbine, this turbine is more efficient. So more green power component can be generated, can be given to the grid with the same element of CLFR. Now green at a comparatively lower operating cost also, because the turbine is not there, single turbine is there, so that can be utilized for this purpose also. Okay, I think that's all. Thank you for the attention.